Welcome to the landing gear and brakes lesson. This lesson covers the components, indications, and basic operation of the landing gear and braking systems. The 787 has two main landing gear and a single nose gear. Each main gear has four wheels in tandem pairs. The nose gear is a conventional two-wheel steerable unit. Hydraulic power for retraction, extension, and steering is supplied by the center hydraulic system. The airplane's electromechanical brake system has 4 electric brake actuator controllers, or EBACs, 4 electric brake actuators, EBAs, on each wheel brake, and a multiple-disc carbon brake on each main gear wheel. The brake system also includes auto brake and anti-skid protection. Controls for the landing gear and brake systems are located throughout the flight deck. Review the landing gear and brake systems controls before pressing the Continue button to resume the lesson. Gear position indications are displayed on the primary ICAS. Additionally, gear door, brake temperature, and tire pressure indications are displayed on the landing gear synoptic page on the MFD. Review the indications before pressing the Continue button to resume the lesson. Flight and ground operation of various airplane systems are controlled by the air-ground sensing system. The system receives air-ground logic signals from sensors located on each main landing gear beam. These signals are used to configure the airplane systems to the appropriate air or ground status. The landing gear are normally controlled with the landing gear lever. While on the ground, the lever is held in the down position by an automatic lever lock. In flight, the lever lock is automatically released through air-ground sensing. If the lever lock is not automatically released, the lock can be manually overridden by pushing and holding the landing gear lever lock override switch. Placing the landing gear lever to the up position begins the gear retraction sequence. After the landing gear lever is moved to up, the landing gear doors open, the gear are unlocked, the ICAS landing gear position indication changes from a green down indication to a white crosshatch in transit indication, and the gear are hydraulically retracted. Once the landing gear are retracted, the landing gear portion of the hydraulic system is automatically depressurized, and the landing gear are held in position by uplocks. When all gear are up and locked, the ICAS landing gear position indication changes to a white up indication for 10 seconds and then blanks. If any gear is not up and locked after the normal transit time, the ICAS caution message, Gear Disagree, is displayed, and the ICAS gear position indication changes to the expanded non-normal format. Additionally, if any hydraulically actuated door is not closed after normal transit time, the ICAS advisory message, Gear Door, is displayed. Placing the landing gear lever to the down position begins the gear extension sequence. After the landing gear lever is moved to down, the landing gear doors open, the gear are unlocked, the in-transit indication is displayed on the ICAS landing gear position indication, and the gear freefall without hydraulic power to the down and locked position. When the gear are down, the down locks are powered to the locked position. All hydraulically actuated gear doors close, and the main gear trucks hydraulically tilt to the flight position. When all gear are down and locked, the ICAS gear position indication displays down in green. If any gear is not locked down after the normal transit time, the ICAS caution message, Gear Disagree, is displayed, and the ICAS gear position indication changes to the expanded non-normal format. If only one brace on a main gear is locked, either drag or side brace not locked, after the normal transit time, the ICAS caution message, Main gear drag brace, left or right, or main gear side brace, left or right, is displayed for the affected gear. And the ICAS gear position indication changes to the expanded non-normal format. Additionally, if any hydraulically actuated door is not closed after the normal transit time, the ICAS advisory message, Gear Door, is displayed. The alternate landing gear extension system uses a dedicated DC-powered electric hydraulic pump and center hydraulic system fluid to extend the landing gear. Alternate landing gear extension is accomplished with the alternate gear switch. The landing gear lever position has no effect on landing gear alternate extension. Selecting down on the alternate gear switch releases all door and gear uplocks and the landing gear freefall to the down and locked position. When the alternate extension system is used, the ICAS landing gear position indication displays in the expanded format. During alternate extension, the ICAS message Gear Door is displayed because all the hydraulically powered gear doors remain open. Following alternate extension, the landing gear can be retracted if the center hydraulic system is operating. Retracting the landing gear can be accomplished by selecting down, then up with the landing gear lever. The airplane is equipped with nose wheel steering, which is powered by the center hydraulic system. Primary steering control is provided by a nose wheel steering tiller for each pilot. The tillers can turn the nose wheels up to 70 degrees in either direction. A pointer on the tiller assembly shows tiller position relative to the neutral setting. Limited steering control is also available through the rudder pedals. The rudder pedals can be used to turn the nose wheels up to 8 degrees in either direction. If both controls are used simultaneously, tiller inputs are summed with rudder pedal inputs, but are still limited to 70 degrees of travel. The brake system is powered by 4 electric brake power supply units. 4 electric brake actuators, or EBAs, are provided on each main landing gear wheel brake to control the application of braking force to the carbon disc. The EBAs are controlled by an electric brake actuator controller, or EBAC. There are 4 EBACs that control all 8 main wheel brakes, each EBAC controlling the brake force of a fore and aft wheel pair. During each manual brake application, the brake control system applies 1/2 of the brakes on each main landing gear. The system sequences through alternating wheel pairs at each brake application, reducing the number of brake applications by each brake. The brake pedal must be fully released to transition to the other 2 brakes on a main landing gear. This system extends the service life, reduces brake sensitivity during taxi, and limits the loads to the airplane structure during pedal brake operation. All active brakes are applied for a heavy brake application, landing rollout, rejected takeoff, or when setting the parking brake. A brake temperature monitor system displays the temperature for each brake on the landing gear synoptic. These values range from 0.0 to 9.9 in increments of 0.1. Normal range values of 0 to 4.9 are displayed in white. For values of 3.0 to 4.9, the brake symbol for the hottest brake on each main gear truck becomes solid white. An ICAS advisory message, brake temperature, displays when any brake registers 5.0 or higher on the gear synoptic display. The brake temperature message disappears once all brake temperatures are below 3.0. The brake temperature value blanks when invalid brake temperature data or faults are detected in the brake temperature system. A tire pressure monitor system displays pressure for each tire on the gear synoptic. Normal values are depicted in white. Values above or below the normal range are depicted in amber. The ICAS advisory message, tire pressure, is displayed if any tire pressure is above or below normal range, or there is an excessive pressure difference between 2 tires on the same axle. Anti-skid protection is provided on an individual main gear wheel basis. When a wheel speed sensor detects a skid, the braking force is reduced until skidding stops. Touchdown and hydroplaning protection is provided using airplane inertial ground speed. Locked wheel protection is provided using a comparison with other wheel speeds. The ICAS advisory message, anti-skid, is displayed if an anti-skid fault affecting the brake system is detected, or the system is completely inoperative. The auto brake system provides automatic braking at pre-selected deceleration rates for landing and at a full rate for rejected takeoff. Anti-skid system protection is also provided during auto brake operation. When selected, ICAS memo messages display the following auto brake settings: Auto brake 1 through 4, Auto brake max, and Auto brake RTO. The ICAS advisory message, auto brake, is displayed if the auto brake system is disarmed or inoperative, the auto brake selector is off but the system is armed, or an RTO is initiated above 85 knots, but auto braking has not been applied. Selecting Rejected Takeoff, or RTO, prior to takeoff arms the auto brake system. The RTO mode can be selected only on the ground. Maximum braking is obtained in this mode. The RTO auto brake setting commands maximum braking pressure if the airplane is on the ground, ground speed is above 85 knots, and both thrust levers are retarded to idle. If a rejected takeoff is initiated at or below 85 knots, the RTO auto brake function does not operate. 5 levels of deceleration can be selected for landing. Auto brake 1 through 4 and auto brake max. The deceleration levels can be changed without disarming the system by rotating the selector. After landing, auto brake application begins when both thrust levers are retarded to idle and the wheels have spun up. This causes auto brake application to occur slightly after main gear touchdown. If Max Auto is selected, deceleration is limited to the auto brake 4 level until pitch angle is less than 1 degree. Then deceleration is increased to the Max Auto level. To maintain the selected airplane deceleration rate during landing, auto brake pressure is reduced as other controls, such as thrust reversers and spoilers, contribute to total deceleration. The auto brake system provides braking to a complete stop or until it is disarmed. The auto brake system disarms and displays the ICAS advisory message "Auto brake" if any of the following occur. Pedal braking is applied. Either thrust lever is advanced after landing. The speed brake lever is moved to the down detent after the speed brakes have deployed on the ground. The disarm or off position is selected on the auto brake selector. An auto brake fault. A normal anti-skid system fault, or a loss of inertial data from the inertial reference units. When the auto brake system disarms after landing, the auto brake selector automatically moves to the disarm position, and power is removed from the auto brake system. When the auto brake system disarms during takeoff, the auto brake selector remains in the RTO position, but will automatically move to off after takeoff. The parking brake is set by fully depressing either the captain's or first officer's brake pedals, pulling the parking brake lever up, then releasing the pedals. The parking brake electric actuators are clamped in position during parking brake application and require no active power to maintain the clamping force. The parking brake system has a park and adjust feature which monitors the condition of the brakes after application and adjusts the clamping force as needed during brake cooling. When the parking brake is set, the ICAS memo message, "Parking brake set," is displayed. If the parking brake is set and either engine is set to takeoff thrust, the takeoff configuration aural alert sounds, and the ICAS warning message, "Configuration parking brake," is displayed. The parking brake is released by depressing either the captain's or first officer's brake pedals until the parking brake lever releases.